Awesome, Andrea. That's great. I hope now, guys, you understand really why operators can be very useful for many applications, complex applications such as Kubeflow, also deployment of databases and management of connected set of components that are building an application, a solution such as WordPress connected to an SQL database, etc. Now with Ben, a very seasoned engineer managers working on the framework, writing operators every day. Let's go into the detail of what has been done so far since the previous operator day. So in the previous 6 months, let's not forget that all the tools that we are promoting here, we are presenting, are actually open source. They are managed by very active communities, all upstreams. So let's listen to Ben that will explain basically how what happened in the previous 6 months. Go ahead, Ben.
Well, thanks, Cedric. My name is Ben Hoyt, and I lead the Charm Tech team here at Canonical. So over the next 20 minutes or so, I'd like to show you how to use the new Juju secrets feature with the Python operator framework, and I'll describe what both of those things are. I've got a small live demo as well, and at the end I'll briefly talk about some upcoming features in Juju for writing charms. So let's get into it. Many of you probably know, but Juju is a tool that deploys applications, or charms as we call them, to a cloud or to a Kubernetes cluster. And Juju manages the lifecycle of these applications, including the data that's shared between them via what are called integrations or relations. Juju itself is written in Go. It's a big engine written in Go. It's a distributed system, client-server model. However, the charms can be written in any language you like. That said, we highly recommend Python. We have a Python operator framework that we promote. It's called Ops for short. And so despite the fact you can write, the Juju engine is agnostic to what language you write them in. We highly recommend Python with the Python operator framework. And we have documentation and best practices built around the Python operator framework, which is kind of like our SDK for Juju. So we use Ops for all of our new charms here at Canonical. It's a lightweight framework that provides a nice Pythonic API, Pythonic interface to the Juju model from the charm's point of view. So anything you could do to anything a charm can do to the Juju model or read from the Juju model has a nice Pythonic API wrapper that's part of the Ops framework. For example, you can interact with relation data, which is the data that's shared between two charms. You can set application or unit status. It's picked up by the Juju status command in the CLI, and so on and so on. What's on the screen here is the full source code for a trivial charm using the Python operator framework. So you'll notice how you inherit from the charm base class. Your charm inherits from charm base, and you can observe the Juju events you're interested in. In this case, we're just observing the config changed event, and you respond to those events in the handler functions. So in this case, the config changed handler only updates the Juju status message. It sets the status to active and sets a message of config updated, and that message appears to that status, and the message appears to the administrator when they type Juju status on the CLI. You'll also note the version number here. The latest version of Ops is 2.2.0, which was just released recently, and support for Juju secrets came out in Ops 2.0. So previously, before Juju secrets, people would use Juju's relation data to share passwords. That goes back a long way. For example, a database charm might be integrated with a web app charm, database here shown on the left and the web app on the right. And the database would tell the web app the username and password needed to connect to it using relation data. So this meant that the passwords weren't rotated, sensitive data was shared in clear text and wasn't stored securely. Not great, but that's where we were. So here in this example, the administrator types Juju integrate database web app, and the super secret password hunter2 is shared using relation data between the database and the web app. So the web app knows the password it should use to connect to the database after that. Problem is, we shouldn't be sending passwords in the clear. We shouldn't be writing our passwords on post-it notes, as it were. So we introduced Juju secrets to fix that. Juju secrets was designed fairly recently, and it was implemented in Juju 3.0 which came out several months ago. Any Juju 3.x version since then will have the secrets feature. So Juju secrets use a backend, we call them secrets backends, such as K8s secrets or HashiCorp Vault, to actually store the sensitive data, keys, passwords, certificates, and so on. Only the secret metadata is stored in the Juju controller. And when deploying a K8s model, Juju uses K8s secrets automatically. So that's, if you simply have a K8s model, Juju will automatically do the right thing and store it as a K8s secret, store the secrets and sensitive data as K8s secrets resources. When an application unit requests secret content, the Juju agent on that unit talks directly to the backend with a time-limited API token. So the database unit agent reaches out to Vault, in this example shown on the screen, with a time-limited API token, and that token's also restricted to only the secrets that unit is allowed to see. So it's all pretty locked down and time-limited. This is done using K8s service accounts, if using the Kubernetes secrets backend, or Vault policies, if using HashiCorp Vault. So everything's nice and secure. Once again, the administrator will type Juju integrate database web app to connect the two together, but this time only the password ID or the secret ID is sent in clear text using relation data. The secret ID is not sensitive itself, but the backing, the content behind it is what's secret, and that's what's stored in the Vault. So in the example shown on the screen, hunter2, the super secret password, will be stored inside HashiCorp Vault, and the database sets it there directly, and the web app receives it there from there directly. So how does Juju manage the life cycle of a secret? It does that using charm events or hooks. So let's say we have a database charm and a web app charm, like in the previous examples. We call the database charm the owner charm because it's the owner of the secret, and the consumer charm is the web app because it's the one consuming the secret. When the Juju administrator integrates the two charms, the database will send the secret's ID to the web app, as we've seen, using relation data, and the web app will fetch the secret's content. When the secret is updated or rotated, so when Juju tells the charm to rotate the secret because it's a day or a week or a month has elapsed, the web app will respond to the secret changed event and fetch the new content. So all the consumer charm has to do is respond to secret changed. When the owner charm, which is the database in this case, adds a secret, it can set a rotation time and an expiry time. And Juju automatically manages those and sends the owner charm events when it needs to create or remove secret content. So these are the three owner charm secret owner events. Secret rotate, which means the charm should create a new secret content for rotation. Secret remove, meaning that a secret has been rotated, all the consumers have picked it up, and now the charm can remove the old secret content that's been rotated out. And secret expired, meaning that the secret's expired and that the secret content should be removed. This on the screen is, and I'm going to show both ends of this picture, but on the screen here is a very minimalist version of what the database charm might look like. So this is the owner charm, the owner of the secret. And I'll walk through it step by step here. It's fairly straightforward. two main methods. In the init method, we respond to the DB relation created. So when the DB relation is created, call this method. Juju calls this hook. And the first thing the hook does is generate a new password, and put it in the dictionary. So this, in the case of SQL, this might be adding a role, adding a user, setting that password, and setting that generated password so the database, other things can access the database. And then on the next line, we call app.addSecret or application.addSecret to actually set the secret, create a new secret, and set the content. Note that we provide a label here so that the charm can look up the secret by label if necessary later on. We set a rotation policy of weekly. So I think there's hourly, daily, weekly, and monthly. And there might be others as well. And in this case, we set an expiry time of 14 days. So that has to be longer. That obviously needs to be longer than the rotation time. The next line grants the view access to the secret, to this relation, to the charm on the other end of the relation, so that it can access the secret. And finally, the secret ID is passed using application relation data, using the name or key password ID. So that's how the other end will pick it up. So now let's flip over to the other end. Very similar structure. We observe in the init method, we observe the relation changed event, and in that event handler, the first thing we do is look up, using relation data, look up the password ID. Then we call model.getSecret to fetch the secret object by ID. Once again, we assign a label. This is a local label to the consumer charm, so it can be different from the other label we saw in the owner side. So we're attaching a local label in case the charm needs to look it up later by label. And second to last line there is secret.getContent. So model.getSecret simply fetches the secret object, metadata, and getContent actually fetches the data. So now we have the password, the dictionary with the password in it. And the final line there updates the web app. For example, that might update the connection detail, database connection details with the new password. So that's all there is to it for a simplistic version. The database charm could also handle rotation. Here we haven't shown the rotation events, but that's just adding another couple of event handlers in the database charm. So next, I would like to show you a little demo of deploying a dummy database and a web app charm along the lines of what I showed on the previous screen. So the code on the previous screens is taken directly from these charms, and we'll go through that now. So that the commands I had on the screen there, we're going to deploy the database, we're going to deploy the web app, we're going to integrate the two, and we're going to watch it happen using Juju status. So let's start with deploying the database charm. It's a local charm, that's why I've got /. It's a local file, but it works just as well, deploying from Charm Hub. And while we're over in this tab, we show Juju status, watched every second. So you can see it's starting up. So while that's deploying the database charm, I'm going to type Juju deploy webapp.charm. Once again, a local charm, so it'll take a few seconds to upload that. I've previously created these database .charm files using Charmcraft pack. Charmcraft is the tool that we use to assemble charms and upload them to the Charm Hub. So now you can see there's two apps, database and web app, with 1 unit each. They're initializing, and so we can go ahead and say Juju integrate database with web app. That'll happen asynchronously, and as soon as the charms come up, okay, you can see they've come up and started printing status messages. So here's the status, and I've made the charms update status so we can see what's going on here. So the database saying added a new secret, and the web app saying I've picked that up and I would update my web app's secret. So they're all integrated. The secret's been swapped, transferred from one to the other. Now let's introspect using some Juju commands for a start. So Juju secrets is the simplest command to show all the secrets in the model. In this case, just one big long secret ID. That's a UUID encoded UUID, but it's you can just treat it as an opaque ID. So now we're going to type Juju show secret with that specific ID, and it shows you the full details in a YAML format, when it's going to be rotated, what the rotation policy is, etc. If we run that command again, show secret with -- reveal, on the end you'll see the content, which includes a key value of password, and the content is pass68. Not particularly secret, but good enough for this demo. And now what we want to do is look at the secret backend. So Juju's concept of the secret backend. So there's two backends listed. The internal controller backend, which isn't being used, so the 0 secrets attached to that one, and the Kubernetes, type Kubernetes backend. This is the model, the demo model. It's called demo, so everything's prefixed with demo, so that's why that demo local. And you can see it's got one secret in it, the one that we just added. Now we're going to use micro K8s kubectl, so the kubectl command, but I'm deploying with micro K8s here, so using the micro K8s version of that. We say namespace, in the namespace demo, get all the secrets. And there's a few listed here. These are sort of Juju internal things, the first three here, and the last one here, which is that same secret ID with a -1 appended, is the secret that we've just created. So we'll repeat that command, but get an individual secret, and we'll say output in YAML format. So now it's spat out all the details of that secret in the K8s secret store, and you'll see the data associated with it is password. That doesn't look like what we had before. It looks encrypted. It's not actually encrypted, it's just base64 encoded. So we can echo that, pipe it through base64-decode, and sure enough, we get pass68, just like we saw from Juju show secret -- reveal. So that's how you can deploy charms, make them share secrets between each other, and introspect those secrets using the Juju tool and the kubectl tool. I'd like to speak briefly on what's coming up in Juju and the operator Python operator framework. In terms of secrets features, the next thing we have planned is what we call user-created secrets. So in the current version of secrets that I've just shown, two charms interact with each other and create and manage the secrets. So the charms manage the secrets. In this case, we had the database charm creating the secret and shared it with the web app charm via the secret ID. With user-created secrets, an administrator will be able to use the Juju CLI to add a specific password and store it in the secrets backend. So this is when you have something like an AWS key or another password stored statically in on a post-it note or hopefully in one password or something like that, and you need to get it into Juju. So rather than a charm created secret, you have a user provided secret that you inject into Juju using the CLI. So you might type something like Juju add secret, and it'll store that in the K8s secret store or whatever secrets backend you're using. The consumer charm will still be able to use model.getSecret to fetch it, and the thing is that currently charmers are using charm config for this. They'll put the secret in the charm configuration and watch the config changed event, but that has all the same problems with sending secrets in the clear, and so this will allow user provided secrets to be stored in a proper secret store. In other news not related to secrets, we have a feature coming up called Pebble Notices, and I'll be working on this along with several others at Canonical. Pebble is I'll be working on this over the next several months. Pebble is the service manager that we use inside K8s charms. It's a service manager that runs inside the container that starts up your services and watches them. And we're adding a notification system to Pebble that will allow the workload to wake up the charm for custom events. So the Pebble notices system will also be used to notify the charm on Pebble health check failures if one of the services fails its health check, or other custom events as they occur. And this will solve a number of use cases to allow the workload to communicate back to the charm, which is difficult to achieve with K8s charms today because the charm and the workload are in different containers. They're sidecars of each other. So I think this is going to be really useful and open up a suite of new possibilities for K8s charms inside Juju. Well, that's all for now. Thank you for listening. We have a Mattermost channel URL listed here, chat.charmhub.io. So you can talk to us on this Mattermost channel at any time outside of operator day. And also check out our Juju SDK docs. The SDK refers to the software development kit, the Python operator framework in this case. So you can check that out at the URL, the juju.is URL above. Feel free to ask questions in the chat now. There should be a couple of folks waiting to answer those. And now back to Cedric.